families of functions, and transformations. So first we're going to start by talking about a parent function. And a parent function is when you don't have any addition, subtraction, multiplication, anything to that function. So I have two examples. One example of a parent function would be y equals x. And this was a graph that you dealt a lot with in Algebra 1. It's just a straight line, positive slope goes through the origin. This is a parent function because nothing has moved this line away from the origin. In Algebra 2, you're also going to see parent functions written like y equals f of x. And f of x just means that it is a function. And I just made this graph up, this blue line. I just drew a function because if we remember that if it were to pass the vertical line test, which let me get my vertical line, this example would be considered a function because my vertical line only touches the blue graph once each time. We'll have many different examples of parent functions as we move through the curriculum, but I just wanted to give you these two right now. All right, so take a minute and you want to write down this model, this formula up here in black. So the y equals negative a times f of x plus or minus h, both of that in parentheses, plus or minus k. And each one of those has a different function as we get into transformations. So if you need to, pause the video, make sure you write this down. And I'm going to go through each section. So just as a reminder, our parent function was the y equals f of x. That was it. Nothing else was around that. It was just y equals f of x. The negative a, h, and k are the possible transformations that can happen. So let's first talk about the negative sign. If there is a negative in the front, that means that there is a reflection of the graph over the x-axis. So that means it is flipped over the x-axis. And if you want, you can write that down instead of reflection. It's also a flip. If we have a number in front of the f of x, or in front of the parent function, that means something different. It can mean that it is a stretch, and that's when that number is bigger than 1, or it can mean a compression, and that's when that number is smaller than 1, meaning it's a fraction of some sort. And so just remember the y equals f of x, that's our parent function. Everything else is a transformation. Okay, the next transformation we're going to talk about is a horizontal shift or a horizontal translation, it's also referred to. And that comes with the letter H. Now this is pretty tricky. So you just have to really keep in mind here that if we are adding a number to the x, if we're adding it, that means we're really going to the left h units. So if this was x plus 3, we would have moved the graph left 3 spaces. If it is minus h, you're really moving it to the right h units. So if the example was x minus 3, we would go to the right 3 units. And finally, at the end, if we add or subtract a number at the end of the parent function, that is our vertical shift up and down. And this one is pretty straightforward. So this one, if we subtract a number at the very end, we move down k units. So if it's a minus 3 at the end, you went down 3 spaces. And if it's plus k, we move up k units. So if it was plus 3 at the end, we would move up 3 spaces. So I know that's a lot of words and it's a lot of general concepts. We are going to do some practicing, but you definitely want to have this written down because we are going to refer to it the rest of the video. So again, if you haven't written everything down, just make sure you pause the video and just write it down and then you can hit play. Okay, let's get into some of the examples. So I have that little formula up here with the colors, hopefully to help trigger a memory for you. So my directions say describe the transformations in each of the following from the parent graph y equals x squared. So that's the key here. My parent graph is y equals x squared. So here's my y equals, here's my x, and here's my squared. That's the parent function. So I need to describe what has changed with the parent function. Well, I notice I have a plus 4 inside with the x. And if I look up here in my model, that plus or minus h, and if I refer back to my notes, that's a horizontal shift. And this is the one that was a little tricky because even though we are adding 4, we are really going to the left 4 units. That's fine if you just want to do left 4, or you can draw an arrow if you want. So you can say left 4. I'm fine with either of those. But that is the only thing that has changed from my parent function of the what I've circled in yellow, y equals x squared. All right, let's do another example. So I have y equals negative x squared minus 7. So again, I'm going to circle in yellow my parent function. I've got y equals and then x squared. That is my parent function. Now what has changed around my parent function? Well, I have this negative sign in the front. And if I refer back to that model, and there's a negative sign in the front, that means there was a reflection, or you can say flip, so reflection over the x-axis. And then I also have a minus 7 at the very end. And again, if I look back at my notes, whenever I was doing a plus or minus k, that's what came at the very end. It came after the parentheses. So I'm going to say comma, I have a reflection and I have a vertical shift down. So I can say this graph is going to be moved down 7. Or if you want to use your arrows, down 7 is fine. But for this example, 2 things happened, 2 transformations. We had a reflection and a shift down. Okay, we got 3 more here. So again, I'm going to circle my parent graph in yellow. So I've got my y equals my x squared. And then I want to talk about what has happened after that. So I do have a number in front now. That's like the letter A. And the A was that stipulation where we had 2 things. It could be a stretch or a compression. In this case, it is considered a compression because the number in front is a fraction. So we would say compression by 1/3. We also have a number inside the parentheses, so we have that minus 4. So since it's a minus 4, that went to the right 4. Or if you want to write it out, you would say right 4. Either one is fine. But those are the 2 transformations from my parent graph. Okay, my next example, so I've got my y equals, again, I'm just circling my parent graph, x squared. Okay, so again, I have a number in the front, so 5. Now 5 is not a fraction, so we would say stretch by 5. And then I have this plus 2. Now it's not inside parentheses, so it's not horizontal. It's considered at the very end. And whenever we have a plus or a minus at the very end, that's our vertical shift. So plus 2, we went up 2. Or again, arrows up 2. That's fine. Now if you want to pause the video and try this last one on your own, that'd be a great way to check and see how you're doing. If you still need to follow along, that's fine too. All right, I'm going to circle my parent graph. So I have y equals x squared. Okay, first thing I notice is I have a negative sign in the front, and that means there is a reflection over the x-axis. And then I also have a minus 3 on the inside. So that means there is a horizontal shift. And since it's minus 3, that means this graph is going to the right 3. And then I also have a minus 9 at the very end, which means the graph is going to move down 9. So that last example had a lot. That had 3 transformations in it. All right, so that's what happens when we have an equation that's given to us. Now these next 3 examples, we're moving backwards. So we're given the words, we need to write the equation. So again, remember, y equals x squared is my parent function. All right, so the first thing I want to do with my parent function is set up a shell. So I know it's y equals x squared. So I'm going to say y equals, I'm going to leave some space, parentheses, x, leave some space, squared. And then I'm just going to fill everything else in. So here, now I have a vertical shift down 3 units. My vertical shift comes at the very end. That is my k. Since I'm moving down 3 units at the very end, I just have minus 3. And that's it. There's only one transformation for that one. And you can leave it like this, you can leave it spaced out, or if you want to rewrite it so it's a little bit cleaner, I'm going to do that in black. It would be y equals x squared minus 3. Again, either one works though. All right. Now for the next one, compression of 1/4. Again, I'm going to set up my parent graph shell. So y equals parentheses x squared with that space. And if I have a compression, that goes with that letter A. So that's the number in the front. So 1/4 goes in the front. And there's nothing else. So that's my answer. And again, in black, I'm just going to clean it up. I'm going to say y equals 1/4 x squared. You can leave it spaced out like we have it, or if you like to just clean it up and rewrite it, that's fine too. All right, and the last one, we have a horizontal shift right 2 units. So again, I'm going to set up my shell, y equals, leave some space, x squared. All right, horizontal shift, that goes inside the parentheses with the x. And since we're moving to the right 2 units, it's really a minus 2. And again, just going to clean it up. So y equals parentheses x minus 2 squared. But we will have to be able to go both ways. So when you're given the transformations, you'll have to write the equation. Or when you're given the equation, you'll have to write down the transformations. But if you have any questions, just make sure to email me or come see me at Bulldog Block.